Cool. What's up, everybody? We have a really big milestone in terms of learning because we're about to go down the path of making things persistent. So, programming, this is true for a lot of, in my opinion, a lot of learning journeys when you're doing web development, whether you're learning Java or Python or doing everything with JavaScript and using Node for the backend or something like that. Once you reach to the point where we can actually persist data and it doesn't just poof away every time we start up our application, it's a huge step forward because then we can do more interesting things with it. Let me start up the shortcuts. All right, cool. It heard me wrong. All right. Um, maybe I just need to speak better. That's like it's fighting me. All right, cool. So in MVC, our model represents the shape and structure of our data. Um, and so you might have a question, well, should we, if our model is the shape and structure of our data, should we then go into SQL and then make tables that match up to our models? You know, look at the properties, make a column for that. That might be a good idea, but there's a good way to do it. There's an established way to do it, and that is going to be using something called Hibernate. Um, so what are we going to be learning about today? We're going to be learning about ORM, Object Relational Mapping, talk about Hibernate for a bit, introduce entities and repositories. So ORM is a programming concept. It does not just exist in the Java ecosystem. It exists elsewhere, like Python and Node, all these other backend languages. So ORM is more of a concept and less of like an actual tool. So ORM is a way to map an object. So for example, like our models, map one of those to the database. And so this would prevent us, the developers, from having to write redundant like database code to match our models, which you could imagine could be really buggy. Because if you had to change a field in your model, then you'd have to go change it somewhere else for the database. And that solution has definitely been tried before. It's just challenging to manage. So that's why ORM is like super useful. And so you can think of ORM as a language interpreter. So it will interpret our Java code into SQL, and it'll interpret the SQL into our Java code. So here's just a visualization. So ORM is translating our Java classes into a database table. So here we have, I removed some of like the annotations and stuff just to keep the example simple. But here we have a class called user. It has an ID, a username, an email, and a password. And then that will Hibernate will automatically create a table with an ID, a username, um, email, and password, and it will figure out the data types, you know, like varchar, integers, or whatever. Right. So that's really just the section for ORM. Any questions about ORM? How it could be used? How it not be used? Anything? No. Okay. So let's talk about Hibernate. So Hibernate is the tool we'll be using to use this concept of ORM. It is an open source Java framework. And when you're like Googling stuff, if you run into errors or whatever, you might see JPA show up quite a bit. And so JPA is like a native Java built-in thing that that is used for ORM like stuff. And so Hibernate is built around JPA. So it uses the JPA logic, and then it just has it's built around that. I'm not exactly sure exactly the extent to which they are different, but I do know that we are using specifically Hibernate. And so if you see JPA, just know that in like an error or anything like that, know that it's referring to Hibernate. So a few things on setting up Hibernate. So the build.gradle file is critical. You've probably encountered this when we've introduced new things to our Java applications, where if you just take maybe an existing project you have, then you were to try to do something new, like connect to a database. Um, if you didn't update your build.gradle file, you're gonna run into some trouble. So for example, for an application that is set up properly to use Hibernate and talk to a database, they're going to have dependencies in the build.gradle file for working with SQL. And so uh, we're not going to really get into like specifically what they are because we're just able to clone projects that are already set up and we have all that already set up. But just know that that's an important thing, especially if you're troubleshooting. The other side of it is our application.properties. If you've already gotten into the SQL stuff and gotten it to work, you've definitely modified this file. And so here is where we have our username, password, and database URL. So for example, hopefully that's not too small, in our, did I call it private.properties? No, it's application.properties. Um, application.properties. So in our application.properties, we will have this spring.datasource.username. I guess it would be considered like an environment variable, but we're hard coding it here. And so here I have it set to McDev, and I have the corresponding password set to a funny way to spell password. If I have it set up that way, I must go into administration and users and make sure that it matches an existing username and password. If it doesn't, I can either make it match or I can just create another user and give it the appropriate permissions and stuff. But yeah, so this is a one-to-one right here. Yes, great question. Question was, can we use the same user account for all of our projects or for multiple projects? Yes, we can. We can, especially since we're just developing, we don't have to worry about protecting credit card data or anything like that. It's just living on our machine. We don't really have to worry about this a whole lot right now, and so it's totally fine and probably very practical to use our same username and password everywhere. Yeah, same user. Great question. Thank you. The other side of it is we also need our database URL. Now this is a funky looking URL right here. The last part after that final slash is what's really relevant to us. So this is our database name. And so we will need to make sure that under schemas, we have a matching database. And if we don't have a matching database, we'll create it inside of MySQL Workbench, I think it is. Using, I believe this right here would work. So if you don't have the database in there, you'll get an error. Probably already seen that. Cool. So questions on setting up Hibernate or just how all this works? Yes. That's a very good question. So the question is, why do we have this port here called 3306? And our application is, when we go to visit our application, we go to like localhost 8080. So you've probably seen that in the URL, localhost 8080. Here we're seeing a different port. The short way to think about it would be there are two different applications running at the same time. So we have our database running, and so therefore it lives at somewhere else. So it lives at port 3306, and then we have our Java application running somewhere else. They're not one thing; they're two things, and they talk to each other. And our Java application will send SQL commands to our database at this address. This is the address it's sending the SQL commands to. And it'll basically retrieve data and do all the CRUD operations that we need. You may see once you start working out there in the professional world that applications will be split up even more than just a Java application and a SQL database. What we may see is that we have our user interface that is its own application. It's running all by itself, kind of like what we were building with Angular. It ran on port 3000, I think, but a lot of times they run on port 3000. And then hypothetically, we could have another application, a Java application. So then our UI and our API or Java application, they would talk to each other with HTTP requests, like post requests, GET requests. We kind of do that now, but it's all inside the Java app. But a lot of times you'll see they live as their own applications. And then the third one would be the database. And so all of these applications, they're going to live on their own port and they're going to communicate in their own ways. Yeah. So hopefully that was bringing more clarity than confusion. That was a really great question. Thank you. Follow-up questions to that? Or anything else? Yes. Between I'm sorry, what? Um, so the question, as I heard it, was: is there a difference between? Okay, the main difference between a dependency and then these values we see in application.properties, right? So the values we see in application.properties, let me just pull one up. So the values we see in here, we can think of these as variables, okay? And so when the Java application is wondering, okay, where does the database live? If we were building Facebook.com, this right here would probably say like Facebook.com, I think the port or something like that. We're running things locally, so it says localhost. So if your Java application wants to know where does the database live, it can just reference this value. It's just a text value. If it needs to connect to the database, it'll need the username and password. And so all of these things are just text values. They're not, at least the way I understand them, they're not anything really special beyond that. The dependencies are addresses. Okay, so this list of dependencies are essentially like entire things of code that live out there on the internet. And so what happens when we start up the project for the first time, it will download each of these. It'll download them from Maven Central. So it'll download each of our dependencies, and the dependencies have code that gets added to the application behind the scenes. And so when we need to do things like connect to like our SQL database, it's going to reference this dependency code package to be able to do that. And so anywhere, let's see if I have an example of this. I'm assuming, I know for sure. Yeah, so this is a really great example. So right here we have org.springframework.data .repository. Hold on. I'm sorry. This is a better one right here. org.springframework.stereotype.repository. So in order to use this @repository annotation that we'll talk about in a minute here, in order to use that annotation, it needs to be able to import the dependency, the actual code. And so yeah, that's what we have going on in build.gradle, which is also why it's so problematic when it doesn't install right. It just breaks the whole application because it's missing code. Yeah. Cool. Great question. Thank you. Follow-up questions to that? Other questions? Yes.
I don't know if you're getting into it later, but can you go over how you would save the credentials as environment variables?
Right. I didn't really get into that so much with this right here. You're referring to changing this to like a variable in here. Um, I know there's a way to do it in an IntelliJ. I haven't quite practiced that. What I will say though is that how you handle environment variables is going to be context dependent. Okay, so for example, if this application was living on the internet, right, it's hosted up in the cloud, um, IntelliJ is not going to be helpful if it stores all of our environment variables inside of IntelliJ, because IntelliJ is not running up in the cloud, our application is. And so therefore we would need a different place to store those environment variables for application to reference. And so I've seen developers, they'll store environment variables inside of a file that's associated with the application. They'll store them literally inside their own, uh, they'll run commands in the terminal to store them at the system level. It's the idea of environment variables is kind of broad. So in terms of having IntelliJ manage them, it's just a place to store the variable. Yeah, if that makes sense. So, I mean, for me, I didn't really practice like figuring out how to configure it just right. So, yeah, cool. Thanks for the question. Other questions? Okay, cool. Great questions. Let's jump back into, there we go. So at entity, so this annotation is going to be how we're going to link our class in Java to our database. So essentially what Hibernate will do to our at entity classes is it will take those and create database tables with them. So you've probably noticed, well, maybe not. Uh, in the reading, we've talked about our model classes. We've referred to them as models. I've noticed that kind of once we get to this point, I don't hear them called models very often. I hear them called entities. It's just a language thing. But so just know that when we're working with entities, it's going to be synonymous with model for in practical terms, right? So our each instance of our entity or each instance of our object represents a row in the table. So we have an example here where we have the user class, which is an entity, meaning it's intended to map to the database. We create a new user, and then using the repository, we save that user in the database, and that gets mapped to a row. And so if we save this 5 times, you'd have like 5 rows that say McDev, right? Um, cool. Oh, sorry. Yeah, so it's still the model. What we're calling an entity is still the model. It's just it is now like maps to the database, and so it's more just me calling out to avoid confusion that you'll at least watching the videos and stuff. I heard the model being referred to as the entity because we now have this entity thing on it, but it's still the model. Still the model. The model is really, you think of it more conceptual. It's more like the concept, and then we have entity, which is implementation. Yes. Yes, this is a typo. I'll fix it later. But yeah, yeah, this should be double quotes, and then this should be an email and double quotes here too. That's both wrong. Hypothetically, though, if that was fixed, this would work. Thanks. Cool. So the syntax for using entity, basically converting our models into something that maps to the database. At a minimum, we need the at entity annotation above our class. And so in this example, we have these other annotations. We have at ID and at generated value. This is very useful. If you remember, we used to do this thing where we would say like static next ID, and then we'd use that to keep track of the ID and we increment it that way. We don't need to do that here. Instead, we're just going to let Hibernate manage that with the database. And so it will generate the IDs for us. We don't need that extra syntax. So this right here is everything that we need to increment IDs on their own. And then here we have, just normal properties. And then what's missing from this example is we don't have any constructors, getters, or setters. Important note. include an empty constructor for all of your models, all of your entity classes. Without this empty constructor, Hibernate is not going to want to create the database or the database table associated with your class. I don't exactly know the technical reason why it gets upset when we don't have an empty constructor, but it does. So just keep in mind if you're running into errors with Hibernate and you just created this entity, not sure why, this would be one of the things to check. Do I have an empty constructor? So take one more chance for questions while we're talking about entities, and then we'll talk about repositories next. Okay. What is a repository and why do I need one? So a repository is essentially the communication channel between our Java application and our SQL database. And so this is going to allow for our CRUD operations, so create, read, update, delete. So if we want to create a new row in the database, if we want to modify it, if we want to delete it, things like that. What does the syntax look like? We will put this in our data folder. It's just as a best practice. And we'll have our imports. And then this is just the line of code for creating the user repository for the user model. Generally speaking, in my opinion, you probably won't mess with this code a lot. You'll set it up. It's kind of like boilerplate code. If you're familiar with that term, it's just a term that refers to just syntax that you just have to create to get something to work, and then you're not really using it or modifying it for the logic. Once we have it set up, this is the part of the repository that we'll be interacting with quite a bit more. So to reference the repository, we will use this thing called @autowired, and then we'll have the type, and then the name of the repository. So hypothetically, if in our controller we want to do things like write things to the database, retrieve things from the database, things like that, we will need this block of code inside of our controller class. We'll need to have AutoWired and then the repository that's managing that communication. So once we have that in place, then within that class we can do things like save a user to the database. And so what it looks like is it says user repository dot save, and then we pass in the object. We pass in the Java object. There's no SQL that we're managing, which is very nice in my opinion. Also, if you think about the hacking example where we wrote our own SQL to get things out of the database, this makes it a lot more difficult for nefarious actor to do if we don't have like plain text SQL in our code. Cool. Now, we'll get into more of this in the future classes, but what we can do with a repository is more than just save a user. We can do things like commands like get by ID, and we can pass an ID, and it'll search the database for a user that matches that ID. And we can do different commands like that allow us to really interact with our database. And we're not writing SQL, we're just interacting with our repository. Yeah, yes. It is I'm not confident that I have the name of it right, but it's a method attached to the repository. So it would be user repository dot name of the method, and then you just pass in the value that you're searching for. Yeah. And if you start messing with them earlier on, you'll run into things like optionals and stuff, which we'll talk about later. But yeah, we can do a lot with our repository. It is how we're communicating with the database. Cool. Other questions? Other comments? Yes. No, that's a good question. So the question was, is each user repository object, this right here, a new row on the table? That was, yeah, right? So no, so the repository is just a middle person. It's just facilitating the communication. When we add a new row to the table, is when we run something like .save user. When we do .save user, the user repository will send a SQL command with the values to create a new row in the table. And so there may be other things like .update or .delete, and that would be essentially the repository would be facilitating sending a delete command to the SQL database. Yeah. Yes. Um, I would imagine that yeah, capital I integer would probably be just fine. Yeah, I I know I copied this. Yeah, shouldn't make a difference. Cool. Other questions? No. All right. So putting it all together. Um, sorry, my watch is not working for me. Anyways, sorry. So we have, from what we've discussed, there are three parts in our code. Not talking about the configuration with the build.gradle and the application.properties. But there are three main areas that we're going to be writing code. In our controllers, we will need the @AutoWired syntax to reference the repository. To interact with our database, we'll need the @AutoWired syntax above the variable that corresponds with the repository. And that's going to allow us to do the CRUD, create, read, update, or delete commands, items in the database. I don't know why I just read that. But yeah, it'll allow us to do the create, read, update things with the database by referencing the repository. But the repository must exist. And so in our data folder, we'll have our repository. And so in here, we'll see the @repository annotation. And then we have that boilerplate code to set up the repository. And then finally, in our models folder, we can't just leave them as regular classes. We actually need tables in our database. And so we'll use this @entity thing so that Hibernate creates associated tables with our models. So you can think of it as like @entity basically enables Hibernate to take our class, our model, and create a database table using those details. Yeah. Cool. So looking at this summary, what questions do y'all have? Anything that's inspired?
That's really all.
Yes. So the one thing, so the question was, is that all that the entity does is just takes a model and allows Hibernate to create rows and columns with it, or just columns with it, technically, table with columns. The one thing I'm not sure without testing is, let's say we as developers had a model without the entity annotation, okay? And then we created a table to look just like it in the database. I think Hibernate would complain if we tried to pass in the non-entity user object. I think Hibernate would complain. It probably is tracking the types, but I don't know without testing it. But yeah, that's essentially what the entity thing is managing is um, the creation of it in the database, and then also I believe the association, so that we don't accidentally pass in a non-user object to the user table. Um, I made a few assumptions in that response, so things would probably be tested out, research. But yeah, cool. Thank you. Other questions? All right, cool. So I don't have a lot planned for this example. I just grabbed um, the exercise code, and so feel pretty good about what we covered. But just to visualize this in IntelliJ to help solidify this connection. All right. So in reverse order of what we covered, um, we'll start in our event controller. I forget there we go. Cool. So this looks like a normal controller for the most part. You'll notice, I mean, it still is a normal controller. It'll look like a controller that we've worked with in the past, but we have this extra block of code here where we say auto wired, and then we have a value event repository. So auto wired is taking this and it is referencing our repository. And now that our repository is wired or auto wired, we can then do things with it. And so you'll notice in this example, they've called find all on event repositories. And so what the repository will do is it will send a SQL command. They'll basically like select star from the events table in the database, and then it will respond. Your database will respond with all of the items, and then this will you'll essentially have it as in your Java. You'll have that data then to work with. Let's see where else is that repository used. Here, inside of the post request in this example, we're referencing the repository again. We're using it to create new items in our database, to save new objects, new instances of the event class. And so here, what would happen here behind the scenes is our Hibernate repository is going to send, I forget the exact SQL syntax, but it will send a SQL command that will add a new row to the database with that data. And then here we have a delete by ID. So this is another option we have. We have just a text ID field, or an integer ID field. And then, so we're referencing the repository quite a bit here. This is where we're really interacting with our repositories inside of our controller. We might expect to see a lot in our repository, but once again, it's really mostly just boilerplate code that allows things to work. So we're going to create it, get it configured, and maybe think about it again if we need to, but maybe not. And then in our models, we have at entity. And so here we have our ID generated value thing. You'll notice that in the constructor, ID is not listed in the constructor. We do not have the ID here, and that's because this is all being managed by Hibernate in our database. Our database is creating our IDs for us, and we really do want that. It prevents us getting into some weird issues in terms of IDs. So we have this awesome ID at generate value. So now we have our ID. We don't have to worry about it. We can name this differently if we wanted to. We could call this event ID. And then in the database, I believe it would just be referred to as event ID inside the database. But so, I mean, other than configuring this and giving it a name, we don't have to think about it a whole lot. Cool. Let's see here. There's not a whole lot else going on inside of our entity, our model, besides these two things to really talk about. Event type is not an entity, so we won't worry about that. And then, of course, we talked about application properties, how important these values are. We want to double check them if we're getting issues. And then if we're doing a new project, we'll probably want to make sure that we have appropriate dependencies. A fast and easy way to do it is just compare it to like a project that works. Yeah. Cool. So I think that's really what I'm planning on covering. So we'll probably have extra time for Studio. Before we break for Studio, I do want to offer a bit more time for questions. You all have had some really good questions. Glad you're thinking about this. Any other thoughts or questions before we break for studio? Okay, cool. Look, studio, and we'll meet back here at 8.